Hello everyone, I'm Kusum Kisi. Today I'll be talking about the time series data and the time series data analysis as a part of our assignment. So let's start with the time series data. So time series data are any data sets which have been collected since a long period of time and they are continuous. So continuity is one of the most important feature of the time series data. So before going to the analysis part, the data should be checked for any incontinuity or any missing data. So if there is any missing data, the data can be filled either by interpolation, which is a very traditional way, or it can be fitted with some model and then the data can be extrapolated. So fitting a model and getting the extrapolated data is a better option. So I'll be using the Kalman filter to fit the to extrapolate the data for the missing part, and the visualization of the data to see if there is any trend present in there, if there is any seasonality present. So that will be done using the plot and graph. So for the trend analysis, we'll be seeing some autocorrelation, partial autocorrelations if the variables are within the different data sets, and if we need to check the dependency of the variables within its own data set, we'll be doing autocorrelation and partial autocorrelation. And if the if the data set is a multivariate one and the variability of one data set, its relation with the other data set is to be checked, we'll be doing the cross correlation. So for the understanding of the trend and pattern present in the data set, we'll be we'll be dividing the combined time series data into the individual individual other time series trends, seasonality and noise, because like all they now combined makes a complete time series data. So we'll be doing the disturbance analysis for the given data set, and then for doing the trend analysis and stationarity analysis, we'll be doing man candle test and augmented decay filler test. So starting with the data set I'll be working with on this assignment. So uh, these are all the data are daily level historical data sets. So I'll be working with the three main data sets, that is Z17 well index, which is the oldest well present in the Edward Aquifer. So it is located in San Antonio. So, and it's looking at the history, the data has been collected since 1932 November 12 till 2023 March 2nd. And the other data set would be the Comal spring discharge and the San Marcos spring discharge. These are both the springs of the Edward Aquifer. So studying their correlations and cross correlations would be good information for analyzing how the water levels and how the discharges are being correlated with the wells and the springs on this Edward Aquifer. So because like the source of water is same for the springs, for Comal spring, Marcus spring, and of course the well. So the data has been collected from the Edward Aquifer website, which is presented here. And so the basic data variable we'll be looking at will be, for the Z17 data, we'll be looking at the water elevation, which is in the feet. For the Comal spring and Marcus spring, we'll be looking at the spring discharge, which unit is in cubic feet per second. So starting with the Z17 well data set, I plotted a continuous data plot and found out that there are some missing data. So first I need to impute the data. So imputing the data, what it does is it fills the gap by extrapolating, by fitting a model, and we have used a Kalman filter model, and then it fills the data with the imputed one. But we need to be sure that it doesn't hamper our mean, median, quartile and maximum and minimum data sets. So it's basically without altering the data that much, it has filled our data set. So this is for the G17 well. I'll be doing the same thing for San Marcos and Comal spring discharge. So the next step after the data imputation is checking for the autocorrelation among the variables itself in the data set. So we can do autocorrelation or partial autocorrelation for that one. So for the G17 we did the autocorrelation. It was done for 6-year round period, and we can see some pattern or changing variability within the time frame on this one, on both autocorrelation and partial autocorrelation. So other thing we'll be doing to analyze the data is averaging. So rolling average is something that helps to smoothen the variability present in the data set, but without changing the feature or nature of data itself. So if you see on the mean medians and quartiles of the original data set, that this is the imputed data set, with the rolling average it doesn't seem changed at all. So but if you see that the rolling average has 9 non-available data, that is the first 9 data is set to 0, and then the first 10 data is the mean of 10 first data. So this is that. So we can see the trend has been preserved, the data nature of the data has been, the autocorrelation and the partial correlation has been also preserved by rolling average. Then for the analysis of the trend and to see if there is any trend in the data or not, first we'll be doing the decomposition of the data to see, like the decomposition function just splits the whole time series data into trend, seasonality, and the random here only represents the noise. So this is the non-needed or unnecessary data information present in the data set. So while doing the analysis, we'll be just ignoring the noise and see if there is trend present in the data set or not. So for the test, we'll be doing the man candle test. For man candle test to for the trend analysis. So null hypothesis, man candle test assumes that the data does not have any trend as the null hypothesis, and if it rejects the null hypothesis, that is the alternate hypothesis. So we'll be doing the total p test for the analysis. So if the p value is less than 0.5, the model rejects the null hypothesis, and if not, uh, either it shows the trend or it doesn't show the trend. So if it rejects the null hypothesis, there is definitely some trend present in the data. So when we did the man candle test in our data set for the J17 well index, we found out that the p-value is very less than 0.05, so which says that our data has some kind of trend present in it. So for the stationarity test, we did augmented decay Fuller test. So the null hypothesis associated with this is that the time series does not have any stationarity, so it is a non-stationary data set, which indicates that the data set has unit root. But like we did this test on J17 dataset and we found out that the p-value is very small, so it accepts the alternate it doesn't reject, it rejects the null hypothesis. So the conclusion is that our dataset is a stationary dataset. So we also did the same thing, like we inputted the data, we did the 10-day rolling average, and also we checked the disturbance present in the data set, and we did the man candle test and augmented decay Fuller test for the Comal spring discharge as well, without hampering any features of mean, median, and quartiles, but eradicating the non-available data set by imputing the data using the Kalman filter. The lag time has been reduced to 3 years on the Comal spring discharge dataset, and for the San Marcos it has been reduced to 1 year, whereas for the J17 well the lag time we took was 6 years. So here you can see the discharge has not been hampered at all. So decomposition, it only splits the data into trend, seasonal, and the randoms. For performing the man candle test and augmented decay Fuller test, we figured out that our data set has some kind of trends on it, and it is a stationary data set. So it was done for the San Marcos spring discharge as well. So decomposition, here also the man candle and the augmented decay Fuller test ended with the hypothesis that we do have the trend and we do have stationarity in our dataset. So after doing the correlation analysis within the dataset, we then move forward for the correlation between these three dataset among themselves, because like the water flowing is the same the water is from the same aquifer, that is Edward Aquifer. So we'll be analyzing the parameters present in the data in these three data sets. So what cross correlation does is that it says how much a data is related with the other data, and it's like if the data set is very long, it helps in visualizing the data set patterns, and as it does the correlation as a function of lag time. So seeing the cross correlation between the J17 well and Comal wells, like we found out that the first day water well data is correlated, highly correlated with the first spring discharge data, as like they have very high peak at the zero lag. The same goes for J17 well index water level and San Marcos spring discharge. And when we compared the Comal spring discharge with the San Marcos spring discharge, the pattern was similar as well. So this was the correlation. So going on to the conclusion, time series data, this should be pre-processed. That is, you need to have continuity on the data set, then we feed the data for data imputation, then we do the correlation analysis, cross correlation, then we do the trend analysis for the data set. So that is how I did the time series analysis. Thank you.